that turned on. Can you see that? All right, we'll be able to get all that. Okay. All right, so in Algebra 2, we're going to pick up where we left off in Algebra 1, and we are going to take these skills and we're going to expand them. And one of the things that I told you is that Algebra 2 has the most different standalone skills than any other math class in high school. Trigonometry may be harder, but it has less things to learn than Algebra 2. Algebra 1 was a major transition from arithmetic, but it had less things to learn than Algebra 2. And so you're going to have a bunch of individual skills that you're going to have to keep and balanced in your mind. All right, and so now where we're starting is we're starting on number systems, because later on we're going to limit the values of x based on certain number systems. All right, so before they do that, they're going to, let's all agree on what a number system is. So digits. All right, what's our number system called? Decimal system. All right, how many numbers are in the decimal system? There's 10. What are they?
0 through 9.
0 through 9. That's 10. That's 10 numbers. That's 10 characters that represent numbers. But because we have different bases, we can put two numbers together. The number to the right is in the ones column. What's the next number? Is in the tens column. So whatever that number is multiplied by 10 and added to the number. And if you have three numbers, the third number is the what?
Hundreds.
Hundreds. All right, and so what we have is we have 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, for the ones place, the tens place, the hundreds, the thousands, and the 10,000s. All right, what happens if we go in the other direction? What's the next number, man?
Tens.
What's the next number if I'm going down on those exponents?
100,000.
No, going this way. What's over here? 10 to the negative 1, which is 1 and a 10 on the bottom, which is commonly called 1/10. The number after that is 10 to the negative 2, which is 1 and 100 on the bottom, which is called 100th. And so the names of our number system come from the powers of 10 because we have a decimal system. Now that's not the only system that you have. Babylonians used a system with 60 characters. So one character represented the numbers 1 through 60, depending on what the character looked like. Isn't that weird? Aren't you glad we only have decimal? Right? Okay. All right, so that's it. Now, integers is up here. Integers are positive or negative whole numbers. So we've got to look at whole numbers first. Whole numbers start at what? Start at what number? 0. All right. The counting numbers start with 1 because I don't count the number of students in here by saying 0, 1, 2, 3. All right. I count with 1. All right. Why did they come up with a 0? Because of subtraction. What is 5 minus 5?
0.
That exists here, but it doesn't exist in both of these. The counting numbers, because you don't count with 0, counting numbers don't deal with subtraction. When people started subtracting, they had to come up with a 0. Arabs were the first 0 in the Western Hemisphere, or in the Eastern Hemisphere. The Mayans came up with a 0 in the Western Hemisphere. Okay, so you have natural numbers, counting numbers, and then you have whole numbers. After you have whole numbers, when you go to negative, you have integers. So those are 3 vocabulary words you should already know, but you can't forget them. Because when we start working with the domain, the values of x, the domain of a particular function, in order for it to be a function with no repeats, we're going to limit the different, instead of real numbers, it may only be integers or whole numbers. So that's the reason for that. All right, now, rational numbers, ratio is a what? Starts with F. Ratio is a fraction. So you have a number on the top, a number on the bottom. That's a ratio. Those are rational numbers. Repeating decimals are rational. They are ratios. Okay, and I think we proved that last year. All right, what is an irrational number? All right, an irrational number is a square root that is not perfect. And so when you put the irrational number in the calculator, you're going to get it filled with numbers, but there's no repeating pattern. All right, now real numbers are all positive and negative numbers. This is the normal system we use. Imaginary, we've talked about. A complex number has a real and an imaginary. And then the book uses transcendental numbers. And 2 years ago, I had to look it up. I've never heard of it before. So the main transcendental number we're going to use is pi. But sine, cosine are transcendental numbers. E, which is 2.768, something or other, big, e to some power is all right, when you have a base raised to a root as a power, that's called transitional, and logarithms and some other stuff. But basically, after we get out of the first chapter, this never shows up again. You deal with it. Okay? All right, now, next part is something that we should do, you should know. The KD properties, commutative, associative, distributive, identity, and inverse. I don't care which order those two I's are in. Then you have multiplication. There are two of them, multiplication by 0, multiplication by -1. There are 4 equalities, equality of multiply, divide, add, subtract. Then RST, the reflexive, there's one equation, x equals x. Symmetric, if x equals y, then y equals x, has 2 equations. And then the last one, transitive, has 3 equations. If x equals y and y equals z, then x equals z. All right, so I like to go RST 1, 2, 3 is my memory tool. All right, and so I saw several people have already been trying to review that again. All right, that will be important. Okay, now let us look. Okay, I've already done this one. Okay, repeating and terminating decimals are what kind of numbers? Repeating decimals. All right, put in your calculator, get your calculator out, put 2 divided by 7 in your calculator. All right, 2 divided by 7. All right, now, without clearing it, put 4 divided by 9 in your calculator. Okay, which one is repeating?
4 divided by 9.
All right, so is the first one.
Oh, yeah, that's it.
Look at it. Look at it. It's a 6-digit repeating decimal. Okay. And now, our calculators barely catch it because you only catch the last 2. Right? But division by 7, now, they are rational numbers because what did you put in the calculator? Starts with an F.
Fraction.
You put a fraction in the calculator, right? And fractions are rational numbers. They are the ratios. So those things that you're looking at in decimal form are ratio results. All right, so repeating decimals, the reason I said that, repeating decimals are rational. Most of the time in Algebra 1, students get repeating decimals or irrational. Right, and that's what I'm trying to stop. All right, so if you already knew that, then that's good. All right, so, all right, now, we're going to stop this for a second. Look at page 3 in your book. Okay. What you're supposed to do is put a check under each of the columns that apply to each number. So let's look at number 5a. Okay, is 5 an integer? Is it an integer is a positive or negative? So put a little check in that box for under integer for 5. All right, just don't make it deep in case you have to. All right, now let's go to the next one. What about, is it a digit? Is 5 a digit? Okay, put a check by it. All right, is 5 an even number? No, then don't put a check. All right, so it must be odd. Is 5 a positive number?
Yes.
Yes, so put a check. Is 5 a negative number?
No.
Don't put a check. All right, is it rational? Can you represent 5 as a fraction?
Yes.
Yes.
Sure, then it's rational. 5 over 1 or 10 over 2, whatever you want to choose. All right, is it irrational?
No.
No, if it's irrational, it's going to be a square root of a non-perfect square. Okay, so looking right down there, look at D. Is D going to be irrational? Yes. What about next one? Square root of 16.
No.
No, that is a whole number. It'll be an integer. It'll be rational. All right, what about the one under that?
Yes.
Negative 16.
Oh, negative 16? Sorry.
Negative
I looked at the
16.
wrong one. Yes.
Negative 16 is not, because you cannot multiply two numbers together and end up with negative, so it's an imaginary number. But we'll get to that. All right, that's the reason for some of those. Now, go in number 5 again. Is 5 real? Yes. Okay. Is 5 a natural number? Natural numbers start with 1 and then continue on up. Yes, it is. All right, is it a counting number?
Yes.
Yes, it is. Is it a transcendental number?
No.
No. Transcendentals are weird stuff. All right, transcendentals are right there. And again, you'll have that as a handout that you can print out and put in your notes. Okay? Now, so that's what you're going to do for the rest of those, just to get used to doing that. All right, that's chapter 1. Now, chapter 2, turn to page 4. All right, because we are doing our chapter Katie properties, the only new piece of information is the first one, closure. All right, so in your notes, I want you to copy what is closure. Right, for real numbers, this is what they say. For real numbers are closed under addition and multiplication because x plus y is real, right? X times y is real, all right? Now, if you have subtraction, is subtraction closed under whole numbers? All right, what are whole numbers would be the first question. Okay, so now we're back to this. All right, what are whole numbers? Starting with 0 and going up. All right, is it closed under adding? If you add any of those two numbers, are you still going to have a whole number?
Yes.
Okay, good. What about multiply?
Yes.
Yes. All right, what about divide?
No.
No, because 1 divided by 2 is a half. That's not a whole number. All right, what about subtract?
Not always.
You can get negative, right? Negative, so whole numbers are not closed for subtraction, but whole numbers are closed for addition and multiplication. That's what closure is talking about. Okay, now, if you have integers, are integers closed under exponents? If you take an integer and raise it to a power, will you still end up with an integer?
Yes.
Sure, it'd just be a big number. Might be positive or negative, but it'd just be a big number. All right, are integers closed under roots, under square roots?
No.
Why?
Because it would be a decimal. It wouldn't be a whole number.
All right, okay, all right, not all square roots are perfect squares, so it will not be closed because you could end up with a non-integer real answer. But what happens if you take the square root of a negative number? Square root of a negative number is not even real, right? And so obviously, taking square roots of integers is not closed. That's what the closure rule is called about. Does that make sense? All right, Ben, are you okay with that? All right, okay, so now closure is something that's going to come back later on. Okay, so make sure that you've got that in your notes. All right. Okay. All right, now. So if you flip over to page 8. I need to check. Yeah, do 1, 2, 3, 4, 9, and 10. 1, 2, 3, 4, and then 9 and 10. That is going to develop, that's where you're going to use your closure rule and also identifying your field axioms. Okay. All right, now chapter 3, page 9. All right, chapter 3, variables, not anything new. All right, turn the page, expression. The last one at the bottom of page 10, exponentiation. What does that mean? Exponentiation, what's it start with? See the word exponent? Okay, that's the adjective form of exponent. Like multiplication is multiplied, or multiplication. Well, making an exponent is exponentiation. Okay, all right. Now, order of operations we understand on page 11. All right, turn the page. All right, there's some examples. Now, I want to get the example number 3 on page 12. Okay, you got your calculators? Okay. Let's see. All right. If you have a new calculator, do you have a calculator? Okay, good. Old one. Okay, I'm going to get the old one because some of the old ones, the technology hadn't improved. So, all right, we're going to look at the square root function. Looking at absolute value of the square root of, the absolute value of 17 minus 4x minus 2. Okay, now here's my question. If you had to put that in the calculator under y equals, all right, so press y equals up at the top. See? Now, y equals gives you a whole bunch of equations. So in the first equation, we want to put in the absolute value. Now, where is it located? There is a function for absolute value. It is in math. Third button down is math. Okay, then go arrow over 1 so you're on number. And if you'll notice, the first thing says AVS. Guess what it stands for? Absolute value. So because we're on it, if you press enter or press 1, it's going to take you back and it's going to say absolute value. Now, we have to put the equation that's inside the absolute value lines inside of this grouping system. So, we're going to take 17 minus 4x and put it after the parentheses. 17 minus 4, and the X button is up in the top, second row, second one down from the top. And then you have to close the parenthesis or exit out, depending on whether you have a new calculator or an old calculator. Now, according to the problem, then we have to do -2 after that. All right, so you should look something like that. Okay, all right, you got that. Now, here you have to exit out with the arrow. Top arrow. Now put -2. Good. Good. Wait a minute. Where's Prince? Oh, you got bricks. Okay, good.
So where we put the bricks?
All right, yours, you've already got it. You had to exit out of that. That's the newer version. All right, you should be okay. Yeah. See, now. All right, okay, the older, all right, you got it. See, mine's an older calculator.
You can see those smiling underneath.
Okay, now, did all of you have to exit out of that and put the other bracket in it?
Yeah.
Or, okay, all right, good. That tells me, all right, so everybody's got the one version higher than this calculator, although they look the same.
Yeah.
All right, now, okay, so here's what's going to happen. When you get the newer one, the only thing different is that there's different colors on the graphs. Okay,
It's
now.
fun.
So now let's go to graph, which is the button on the top all the way on the right. And let's look at what it looks like. Whoa,
Oh, there's an error.
why?
Mine has a bunch of lines.
No! It just lost everything. Nope. Never mind.
Get with the equation there.
Oh, I see why mine, because I've got something else
What's this?
in there. Okay, hang on.
Okay.
It should, okay, if you look at it, it should give you a V.
Yeah.
All right, so whose didn't give a V?
When you press graph, it goes to.
All right, wait, do you have a minus or subtract sign? Let's go back to the equation.
Oh, I think the minus is.
First press one. Okay, y equals.
If it's subtract.
Is that a subtract or is that a negative?
A subtract?
Double check it. Clear it out, clear the whole thing out. Just clear. Okay. All right, absolute value, math. Math. All right, go to none, absolute value is 1. Okay, and then you're doing 17 minus 4x.
I don't have the X button, so.
Yeah, X button's right there.
Oh,
Okay, there you go.
that's probably what the problem
That's
is.
why.
I
Okay, you
typed
get
in
it?
alpha X.
Okay, let's see what you.
Nope.
You don't have anything in there. Why? No, because you're trying to grab a dot. Oh, okay, so let's put it back in. All right. Math. All right.
Yes. Wait.
17 minus 4x. Now, gets it out. We go -2. Now press graph. Okay, let's see what.
What did you get when you pressed minus, or when you pressed graph? Did you get it? Oh, you actually got a.
Oh, I already do. I got a button.
See every time though.
This is window range as well.
Maybe I gotta highlight that in the graph. No.
All right, this, you've got, I don't know how you got these numbers in, but we're going to do -20.
Let's try minus 20.
And then -20.
Nope.
So you did it right. Just, let's see.
Your calculators work.
Invalid.
Values in the examiner. Did yours work?
Yeah.
Yeah.
Mine didn't do it.
Let me just figure it out.
of this. Components.
I can't get mine to work either, but if that helps, I've been trying 30 different ways. Remember yours work? Of course.
I think so. It's different.
You got your off. Oh, what?
Wait, that's not
This is
mine.
dimensional.
Mine is like, no, that's not a V. That's like,
That's a very straight V there, Harvey.
It's a, I mean, it's a line, at least it's better than this.
It's an ancient contract, so
I mean, you just gotta flip it one way.
We'll have to figure it out. The only thing we can count, once we can do is,
It says that this. I know what the problem is, I just don't know how it is.
Press
I
it,
need to
but
probably
if
look
you
that up.
type into it, it stays on.
Can you see
Let me see what your, hang on a second. All right, okay. The only thing you have in here is a
I
six.
promise I'm not going to mess anything up.
So why not, you're supposed to have an
I'm just trying to
equation.
see what your windows are.
So let's go right here and go
So
math
X-Men is
over 1,
negative 10.
absolute value. Now 17 minus 4x, close parentheses, then subtract 2. Now
Okay.
go to,
And then just press enter and it should get you out.
say, wait a minute, okay, now.
And then go back to
Now you got
the
it.
ground and it
Back
should
to
be
it again.
So let's see.
Turn it off.
yeah, and
Oh, the battery's low.
There we go. And now I got a line.
Okay, sorry, okay.
Did you get a
All
line?
right, now, we hit,
I got a V.
all right, pardon me for this particular thing. We had two calculators that weren't working well. So, all right, now, the reason that I was trying to show you that is that you can put that equation into the calculator and be able to get some idea. But if you're going to do an absolute value problem, absolute value of 17 minus 4x is equal to what? What did the problem say?
minus.
One.
All right,
Minus 2.
minus 2. So it's going to equal 2.
No.
It's minus 2.
All right, minus 2. Okay. Oh, I see. Wait a minute. That's not an equation then.
Well,
It's an evaluate.
Oh, okay. You're just all right. So, okay. Oh, I see. I read the problem wrong. So, in order to be able to evaluate that when x is 3, okay, here's what I want you to do. Go to the table, which is second, the last button. Go second table. Go down to where x is 3, and tell me what you see. You see a y of,
Do you have to clear the first?
no, just go to, all right, go, okay, here. X up, or come up to where, keep going up. Where are you going? Why is he going more negative?
Second graph, which is the
Okay, the next is 3, y is,
X in the third X.
yeah, present. Second table. All right. See, this is going the opposite way. That's weird. You got something set up with her. Okay, so when x is 3, y is 3. What happens when x is 5?
It is 1.
5 is, okay, so this, other than calculating it, other than using store into x, if you put the equation into y equals, then you can see all the values of x, and later on we'll find that even if it was a fraction, instead of having the x's change every 1, we could have it change every 1/3. And I'll show you that later. Okay? All right, now, in examples 4 and 5, you've got expressions that you're trying to solve. They're going to give you the values of x. All right, so turn to page 15 now. Okay. So, page 15 is calculator work. All right, do you remember store?
Yes.
You remember store? For those that are looking at the, because we've got one student in social circle is going to be viewing this tape. All right, so to press store, all right, let's say you want x to be a value. Right now, press x on your calculator and then press enter. All right, okay, tell me what value came up.
10.
10, somebody else. All right, Ben, you should have 0 when you press X and enter.
I can't get out. Just turn it
All right.
Do we clear the X and Y screen?
Yes, yeah, you go second quit. Second quit to get out.
Okay.
All right, now press X and then enter. What do you get? 7? 10, okay. All right, okay. So if you want a different number, let's say you want 4. In the calculator, you go 4 and then enter. Okay, now that number, you're going to store it to X. So press the stow button and you're going to see an arrow, and then X is up at the top. Press X and you'll see that. When you press enter, you're going to get 4 again. That means X is now 4. Okay, let's go over that one more time. Clear everything out. All right, we're going to store 22 to X. So press 22 and then enter. Now, 22 is the number. So press stow and you're going to see an arrow. Then press X and you're going to see the X come up there. When you press enter, it's going to say 22 is now an X. Okay, now what's 4 times 22?
88.
88. Put 4x in your calculator. 4x, Ben. 4x, enter. 88. Okay? Now, why did I show you that? Because in this section, in 1-3, you're going to change the value of x in the same expression. Okay? Now, we just did 4x. All right, let's change x to negative 2.3. So put negative, which is at the very bottom, 2.3, stow x. All right, now press enter, and now you should have negative 2.3. Go second enter, and come back to 4 times x. Now you should have 9 point something, right? Okay, why is it positive? Because you're multiplying 4 negative numbers together, so you're going to have a positive answer. Okay, so that's store, that's stow. All right, you need to begin to understand store. So in section 1-3, practice store. Now, why is that important? I'll explain. Suppose that I gave you this problem. Suppose I give you that problem. All right, and you go all the way down and you find that x is equal to 2.3. Okay? So you need to check it, make sure it works. So put 2.3 in your calculator, store it to x, stow x, enter, 2.3. Now, copy this half of the equation. Copy in your calculator 3x plus 2 parentheses 5x minus 4, close parentheses. Now, we already have x stored to there, so when you press enter, you'll have the value of this side of the equation. Without clearing it, you put this side in. Those two numbers should match if that's the right answer. So now put, without clearing it, 7x minus 15 plus 4 times 2x minus 1. Now the two numbers you get, because I just made it up, the two numbers you get don't match, do they? Therefore, there's an algebra mistake. That's not the right answer, because if it was, then both of those equations would have produced the same value. Now, that's the reason you learn store, is that when you have an equation and you're done, you store the answer, then you don't have to replace this with 2.3. Right? Because it's x, because I've already stored what my value of x has to be. All right, does that make sense? All right, now again, that brings your math ability level up one step without doing any additional work. The calculator's doing the work for you. Okay? All right, now, polynomials. Turn to page 17. Now, I think we had this last year too. All right, polynomials have names. All right? The name, if there's one term, the name is monomial. If there's two terms, the name is binomial. 3 terms, the name is trinomial. And anything that's greater than or equal to 4 terms is a 4-term polynomial, a 6-term polynomial. Terms are things that are added together or subtracted. So there would be 6 different things if it was a 6-term polynomial. All right, now, so that's for terms. All right, for exponents, you have, if there's no exponent, it's called a constant. If there's exponent with a power of 1, it's linear. 2 is quadratic, 3 cubic, 4 quartic, 5 is quintic, and anything above 5 is a 6-degree polynomial, an 8-degree polynomial. Now, the only thing different that I need to be able to caution you is that if you have 4x to the 3rd, y to the 5th, what is the degree of that term? It's the total of the exponents. All right, there's 2 variables. The total of the exponents is 7. 7, right? The 2 and 5? The total is 7. So that is a 7th degree monomial. All right, now, most of the time, you only have one variable in the term. And so whatever the variable exponent is becomes the number as far as the value of the term is concerned. So this would be a cubic, right? This would be a cubic, right? Because it's 3. But this is not a quadratic. It's a 7th degree. So do you see the caution? All right, we're so used to seeing just one that when you get 2 variables, or what's worse, suppose I give you this. All right, what's the degree of that monomial?
5.
5. How'd you get that?
There's 1x, the 1 is implied.
Yeah, there's 1x, there's 3y, and there's 1z, so that's a 5th degree, which would be a quintic. Okay, I got that? All right, the rest of that is just work. Okay, turn to page 18. All right, there's names and examples. All right, I've got that on the board. So that should handle all of that section. All right, now section 5. Let's see, wait a minute, let me double check how far I Catherine? No? Okay, not here. Whoops. All right, Josh is here. Elise, right? Yeah. All right, Gavin. Josh. Oh, Gavin's not here.
Josh is or
Huh?
Gavin's a remote student. He's doing it online.
How
He's
do I
going to be
know?
remote.
I didn't know that. All right, Ben. Henry. Okay. All right, now. Teacher page. Hopefully it's going to turn. There it goes. All right, so yeah, you're going to do 1 through 4. Okay, so the assignments for this particular week, and this is now up on the teacher page. This is the teacher page from my view. All right, you're going to do in problems 1, you're going to do 1, 3, 6, and 7. Then in section 1, 2, you're going to do Q1 through 10. That's the quick problems, and then 2, 4, 6, 8, 9, and 10. All right. Then for section 3, you're going to do 1 through 10, but I'm going to have you do 14 through 32. All right, and so if you will turn to page 15. Turn to page 15. All right, on page 15, if you start with 14, now if you notice the problem says when x is 2 and x is negative 3. All right, now you could substitute and do the math work by hand. You can use store, and you would store x is negative 2. In fact, let's do that. All right, let's do that. Now, okay, first of all, wait a minute. I'm going to do it in an order that you would find. Let's put problem 11 in the calculator without doing store first. In the main screen of your calculator, clear it, and put in 4x minus 1. Put in 4x minus 1. Now, when you press enter, you're going to get whatever the value of x was. All right, but what we want is we want x to be 2. So now we have the calculator, we have the equation or expression. Now we're going to take 2 store to x. Press enter, and you should see a 2. Now, to get back to that equation that you've already entered, you're going to use second enter, second enter. So press second, enter, and then second, enter, and you'll see 4x minus 1 is now shown up. Now, x is now 2, so when I press enter on this one, it'll be the correct answer. Right? And you get 7. Right? Okay, so the reason I'm showing you that way is that often you put the equation in and then, oh, I didn't change the x. Right? So you can go ahead and store the correct number to x and then go back to that equation without re-entering it. Now obviously 4x minus 1, you could have just as easily thrown that in. But if it was a long trinomial and you didn't want to have to go through and put all of those things back in again, you can use second enter to get back. Okay? Does that make sense? All right, now, if you need to put that in your notes, that may be something good to do. All right, if you know how to do that. And so that is going to help you do those particular problems on that page. And then the simplifying by expression on the bottom is just a little bit of math work, making sure that you know how to handle the negatives. Okay. All right, now, in section 1.4, I'm not assigning the quick ones, the Q1 so you're only, of the 4 sections, you're going to do 2 Qs. All right, I'm trying to be nice. All right, I want you to spend time learning how to do the things that we're talking about and not just spend time getting answers from it. So on 1.4, you're going to do 2 through 24 even, 2 through 24 even, and then you're going to jump down and also do problem 34. So what you're doing here is you're looking at those expressions and you're going to tell me what the type as far as term is concerned and what the degree is. So if you look at problem 15, look at problem 15. How many terms are in problem 15? All right, how many different things do you see being added or subtracted?
6.
In problem 15, how many things are being added? There's 2. There's the first thing minus the second thing. So there's 2. So that is, that has 2 terms, right? Now, what's the degree? The degree is the sum of the exponents of the variables. So in problem 15, it says x cubed y second, so the degree is 5. Okay, that's all that is. Okay. All right, and now, number 34 I'm not going to talk about because I want to see how you do that. All right, now, turn over briefly to page 25. All right, if you look on page 25, this is why chapter 1 is important. Because in problem number 2, you're being asked something in the real number system, so there's no restrictions. But in problem 3, you're asked for x to be positive numbers. So that means that you have a limit because x is not going to be a negative. So that's going to limit the range. That's going to limit the answer because you can only, your input is restricted. Okay? So that, and again, that is a concept issue that may be tough, and we'll talk a little bit about that next week. Okay? Let's see. Well, we're right on time. Thank you, Lord. All right, now, inequalities was the next chapter. Again, we're going to get into that next week. Turn to page 29. Look at the graph on example 3, which is the top of page 29. All right, what do you notice in that graph? You notice 2 circles on the end? Are they the same?
No.
All right, you should already know how to represent both circles. All right? The one that is closed or the one that is dark, what do you have to add? You have to add an equal sign underneath it. Okay, now, from the dot at -1, are you going up or down? Up. So you're getting greater. So x is greater than -1, right? Okay, now here's what I want you to see about that. All right, if x, now the greater sign, the open end is toward the x, right? X is greater than -1. You write it backwards. Now, what about on the top end? Oh, wait a minute. It's greater than or equal to -1. Now, on the other side, it says that x is less than 3. X is less than 3. Right? So when you write a dual inequality, when we get there, you put the x down, you write one backwards and one forwards, and you write a dual inequality. That way you're not doing two of them. Right? And we're going to get smart enough to be able to do two of them. Okay? All right, now we've covered a lot of work. All right, any questions about the things that I've gone over quickly? All right, this work is not in your homework. Okay, so what are we doing? We're doing 1, 2, 3, and 4. All right, now, did I give you the jump drives? Okay, all right, now, I have changed some of the assignments. So go by what's on the teacher page. Do not go necessarily by what's there unless you just want to do more to practice, which is okay. If you're not certain and you're not saying, boy, this is easy, or man, I really get it. If you're not in that way, then you might want to practice some extra problems. Okay. Also remember that the solutions are on videos on your jump drive. And so if you get stuck on what to do, you can listen on how, whatever that guy's name is, how he does it. All right. Third thing you can do is if you're really stuck and you really want to know, email me. All right. And I'll try to get back to you in a reasonable manner. I'm not always home, but I look at it quite often when I am home. Okay. Any other questions? All right. Good. Well, we are done. Tell me this go off, Josh.